So, hello, good afternoon here from Betzigau and welcome to a new webinar. Today we will focus on the cement industry. My name is Nicolas Oppenberger, product manager at UWT, and I'm happy to have a very experienced and sympathetic person by my side today. Hello, Goyen.
Hi, good afternoon. Welcome to UWT podcast, Cement and Building Special. My name is Guo Yan. I'm the area sales manager for Asian and Pacific. And before we get started, I want to clarify one important thing. Nicholas and I, we are fully conformed with Corona hygiene regulation. So we have been tested and the results are positively negative. So we are safe and clean. That's why we could stand side by side and present this podcast for you. Let's get started.
Yeah, thank you, Goyen. Let's get started. So we're focusing today on the cement and building industry to give you a short guideline of what to expect during the next 30 to 35 minutes. So I will start with some requirements that are typical for the cement industry. Then we'll go on and hand over to Goyen. She will give you a short overview of the different processes in the cement industry, and then we will hand over to some success stories to what we already solved with our products in the cement industry. So the special requirement in the cement industry, generally spoken, is a harsh environment. So we have dust, we have corrosion, we have high temperature application, we have material that is pretty sticky, so it tends to build up. We have a lot of mechanical forces working on our sensors due to this high bulk weight of the materials, condensation, and also most of the application do require dust X approvals.
So now I would like to give you a very short introduction about the process flow at the cement industry. So the cement production started at the quarry, where the raw materials have been started and evaluated. Once they get qualified, they will be conveyed to the crusher. Here, the raw materials will be crushed down to the size which is suitable for feeding for the processing. To assure high quality of the final product, the raw materials need to be conveyed to the blending belt and homogenized properly. Afterwards, they will be forwarded to the storage silo for the next process. In the raw grading mill, the raw materials will be dragged and dried and pulverized, and with the help of the hot gas from the Q system and conveyed to the ESP filters. There, they will be separated from the hot gas and further conveyed to the storage silo. Here again, the raw materials will be homogenized and in order to reach an ideal level of the chemical composition. And then the raw materials will be burned in the rotary kiln. Here, the clinker will be produced. Before the clinker move out of the rotary kiln, the temperature could reach to 1,300 degrees. And we have to reduce it in order to store them for maximum 200 degrees. Then it will be stored for next step of the process. In the vertical mill, the clinker will be mixed together with different type of adjectives. Depends on the adjectives to be added, gypsum, sand, or fly ash. All the properties or the fineness of the clinker, the final cement product will be different. That's why the final cement product will be stored in a tall storage silo and ready for loading. So followed by that, and we are going to show you some success story where in different process where UWT sensors have been proven to be ideal for all these processes. Now we started from the first raw material handling, the conveyor belt application. After being crushed, the gravel and sand are transported on a conveyor and stored in a large stockpiles. To avoid of any damage, the conveyor's limit switch is installed to indicate a high stockpile. The very special challenges are here, the movement of the conveyors and open air application. So Nicholas, would be so kind and tell us what will be the suitable sensor for this application and why?
So yeah, thank you, Goyen, for this nice description of the process. What we used here was our RF Nivo 3100, but with the heavy duty version. So this is what you can see here. I have it in my hands, this really robust design of the RF Nivo for the most challenging conditions. What is special about the sensor is the high sensitivity. So the sensor does not have to be fully covered with material, so it's sufficient to get a little bit of a coverage of this type here of the lower part, and then it immediately reacts. So it has also a fast reaction time. Another great feature is that it is completely simple to calibrate. So we have this automatic calibration. So you only have to push one button and then the sensor automatically calibrates to the special application condition. And for this application, it was also important to have this robust design. So this is what you can see here. And also you can feel it when you lift our sensor. It's pretty heavy. And here you can feel in the robust design here. So this was a very nice application with our RF Nivo.
Thank you very much, Nicholas. Let's move to the next application. So that is for raw mill silo. To ensure the continuous production, the raw materials are stored in a big silos or large bunkers. Here, the special challenges are the Darcy environment, long measuring range, 30, 40, 50 meters, and condensation buildup existing there. So, Nicholas, what will be the suitable sensor here?
So here we have as a first option our Nivo radar here. It's what you can see here in my hands. It's our non-contact level measurement based on the radar principle. We have the state-of-the-art 78 gigahertz technology, and also with this narrow beam angle. This is pretty important for higher silos. Maybe if when there are installation inside the tank, you do not see them, so you do not get any fault signals from installation or tank walls, silo walls. It can also measure very high silos, so up to 100 meters. And what is also important, especially in the cement industry, where we have harsh environment that is independent of dust, condensation, noise, or any temperature drifts. So pretty flexible design. And what is also important to mention, it is easy to set up. Yeah, just plug it on. And with our display here on top of the unit, we have a guided setup menu. So it's 6 steps where you get guided through, and then the sensor is easily and fast calibrated to the specific application.
Oh, thank you very much. But I need to ask you a question.
Yeah.
Maybe you can explain a little bit why this flange looks a little bit special. It's not like that flat flange we know normally.
Yeah, this is called the aiming flange. So as you know, in most of the solid application, we have this conical surface due to the filling. And with this aiming flange, you can align the sensor towards the top of this cone. So you can be pretty flexible. So wherever you want to measure, you can align it here with this aiming flange to the right position then.
Yeah, that's definitely a very useful feature. Thank you very much. So let's move to the next success story. Again, it's a raw mill silo, the same application, same measuring task. Here we are using a different technology. So Nicholas, would you please go into a little bit more details?
Yeah, the second option is our classic product, our Nivo Bob, what you can find here, what you can see here behind me. Very easy and reliable measurement principle made for also these harsh environments. What we do also have is this little element here. Bring it out. This is what we call the sensor weight, and this is then specific for a certain bulk weight, certain bulk material to get it as sensitive as the application needs it. So different sensor weights. In this raw meal silo, we used the so-called spider sensor weight due to this sensitivity we had. What is also important to know, it's again easy to set up. Yeah, we have a quick setup guide, and we can measure in silos up to 50 meters. In dusty application, important feature is our tape cleaner. So yeah, we get rid of all the dirt and all the dust so that we do have a clean mechanic chamber, what avoids any maintenance or things like that. And we can do have a volume signal. So it's possible to program and indicate a volume signal. So not only the distance or the level, but also we can have a volume signal here.
Wow, thank you very much. So next step, let's move to the next success story. The application in the ESP filter. So the ESP filter cleans the flue gases and generates it during process. And to protect the filter from any damages, the level of the dust deposit needs to be controlled. So the special challenges are extremely dusty environment, light product, corrosion, buildup, and the vibrations. So here, we also have our suitable sensor and suitable solution for you. Can you give us a little bit more details?
Yeah, this time we use the RF Nivo. So again,
sorry, that's dangerous.
The capacitive principle. Here we have this special design with a PFA coating around the probe. So normally the probe is made out of stainless steel and with some PEEK insulations. Special here, also with the standard version, we have the automatic calibration and also a display where we can see the measured capacity. So here again, just one click on a button, and then the sensor automatically calibrates on his own to the specific application condition. It's very resistant due to the coating, and this is important for this corrosive media what we have in the ESP filter. We have an active shield technology, so we can ignore buildup around the probe here, so it has no influence on the measuring result. And we do also have the option with a remote housing. So when we have vibrations in the process, then we can use a remote housing where the electronic is located, and then you will get no damages due to the vibrating of the vessel, of the tank, of the silo or the filter, because the electronic is remote and protected there.
All right, thank you very much.
And again, what we do recommend here is using this type of coating. It's not really necessary, but for this aggressive media, it is just an additional protection.
Yeah, we could extend the lifespan anyway with this option.
Exactly.
All right, thank you very much for this. Sorry. So the next one is a very special success story in the clinker production. So the limestone is burned in the kiln. The furnace is filled from the top with the limestone. The finished product burned limestone and collected at the bottom of the furnace. Here, the extremely challenges the high temperature up to 1,100 degrees. So here we really need a very, very special sensor or solution for this application. So please, Nicholas, give us more details.
Yeah, what we used here was, as a sensor, we used the Nivo radar plus the accessory with the temperature tube, because this, what you already mentioned, the high or extreme temperatures up to 1,100 degrees Celsius, are too much for this single unit. So we need a cooling effect, and this cooling effect comes by the temperature tube. So what we have here, we have a glass inside the tube, and this cooling length where the temperature is reduced from 1,100 degrees Celsius to only 150 near the unit. So then it's no more problem to use the Nivo radar in such an application. What is also a great feature with this temperature tube, that we do not need an additional cooling. So there is no nitrogen cooling necessary. So just use the tube, and the temperature is then reduced to 150 degrees Celsius near the unit. And due to the properties of our electronic due to this 78 gigahertz technology with the narrow beam angle. You do not get any influences of this tube regarding your measurement results. So it stays reliable and yeah, pretty good solution for clinker application.
Yeah, when we're talking about this high temperature, I'm also thinking about automatically the power industry and the power plant and the iron steel industry. Sometimes we also have this really very high temperature application. So that means this solution can be also used in power plant and iron steel industry, right?
Exactly. We have some success stories also there, also with this temperature tube and with our new radar.
Oh, that's good. And yeah, when we're talking about the 1100-degree solutions, we have something additional. So Nicholas, look at this one. So this is our special unit, paddle switch. So would you please explain a little bit more?
Here again, for the high temperature, it's resistant up to 1100 degrees Celsius. It's our rotary pedal, the Rotonevo, one of the most robust version we have with our limit switches. Here you can see the pedal with a bigger wane and an increased diameter here to just withstand this extreme condition, extreme temperature. And what we do also have here is a comparison of how it looks like. So the color has a little bit changed.
Let's compare.
This was.
This is a new one. This is one that has been installed in the process.
Yeah, and you can see it because the temperature changed, but it's still working perfectly. So perfect solution for also those high temperatures.
All right. So let's move further. The next one is the clinker cooler success story. The burned limestone is stored in a very special vessels to cool down. The falling clinker in a vessel combined with a high temperature, this makes the demands on the level instruments. So the special challenges are here, extremely high temperature and a high mechanical load. Now we also need a special solution, right?
Exactly. And this is what we made for this application here. We used RN 3004, but with a reinforced version. And our modular design just allows it to adapt the sensor to any special conditions we have. So here we had a special design of the 3004. We had stainless steel sliding bearing with conical shaped contact. So this was one specialty. Another specialty was the reinforced stainless steel shaft with increased diameter. It's a little bit comparable to the high temperature version. So a bigger diameter for more mechanical load that can work on this shaft, on this pedal. And also we reduced the length of the shaft. So just to reduce also the force on the pedal here and decrease the torque at this point. So we are always open to get some special versions regarding your application. And due to our modular design, it is easily possible for us to also maybe make them more robust if the application needs this.
All right, interesting. Thank you very much. So the next one, the siemens storage silo application. So here in the siemens storage silo, we have also some challenges due to dusty environment and a small process connection. And here we will introduce a different type of technology, right?
Exactly. So what we used here was our third option for continuous level measurement, our Nivo Guide, the version for solid application. So it's a guided wave radar. It's also radar, but guided here along the probe. What makes it special, what makes it quite suitable for cement application is the robust design. So we have here increased stability in the coupling and also a bigger diameter of the rod, so 16 millimeters. Again, easy setup. So we have a quick setup guide, just 5 steps, guided through, and then it's easily configured to the to the application.
Mhm.
We do not have any moving parts, so no maintenance is required. And also radar principle, so we are independent of dust, condensation, noise, or temperature drifts. So yeah, good solution here.
Here, I just get one question. It's frequently asked. Sometimes if you go to the cement plant, then engineers ask me, well, if we order the sensor, but we still do not know what is measuring range. So we also do not know whether we use the road version or road version. Could we interchange the road version or road version, or could we change the length? So these are the frequent asked questions. Could you explain it a bit more?
Yeah, here again, the modular design of our sensors. So you can just, interchange rod to rope, whatever you need, whatever your application need. Just unscrew the rod here. Takes a little time because it's also
it's
stable.
Very fast already.
And then, you have this element here, and there you can then screw in a rope version, enter the new lengths, and also the new lengths can be calibrated automatically. Can be with one push button in the menu, then the sensor automatically measures the new length. And what is also a great feature is that we can cut the rod or the rope on site. So if you do not exactly know which length you need, order it maybe a little bit longer and then cut it on site to the required length, and then you have a perfect solution here. And again, just completely easy and simple to interchange and also to determine then the new lengths.
Very flexible, very, very good solution. Thank you. So the next success story is the bulk cement loading process. So the finished cement is filled into trucks, while the telescope for more efficient truck loading with fewer overspills and automatic shut-off and leveling switches used. Here, the special challenges are very limited installation space, high material throughput, and dusty environment. Here, we also have a suitable solution for you. Please.
Yeah, what we used here was our vibrating fork, the Vibra Nivo 2020. So as all our sensors are, this is completely easy to install, easy configure. So you do not need any calibration. We do not have moving parts here with this vibrating fork, so no maintenance is required. Can be also, the sensitivity can also be set. So maybe you have some materials which may stick on here, the fork, just use the sensitivity, and then it's resistant to some buildup here, and will also work. Recommended for dusty application because it's welded together, so there cannot enter any dirt inside the sensor, and high sensitivity due to the long length of the forks. So we have a high sensitivity here. So this is one solution for those loading bellies.
But for here, I also have one question, because I got some customers, they love to use UWT pedal switches. And so sometimes it's a little bit difficult to convince them to use different technology. And my question is, can they also use pedal switch here for this application?
Yeah, we do have also a special solution for this type of application. This is our Rotonivo 3005, and this Rotonivo looks like this one here. So we have a short extension here, a short shaft, and also this big pedal, so big size of the pedal, what means that it is quite sensitive. So the bigger the pedal, the more sensitive the sensor. And this is also perfectly made for those applications to install it, and then you get
here it's very short. Oh, that's cool. Wow, thank you very much. That sounds very good. So before we finish off, I got one quiz for everyone. Nicholas, would you please be so kind and
of course
bring me that flip chart? Well, I guess very simple quiz for everyone. Well, it is about level sensor demand at the cement plant. My question is, let's say if we have a cement plant with 2,500 ton per day capacity, what do you think how many level sensors do we need on such a plant for the automation? So Nicholas, what do you think? What is your estimation?
My estimation, let me think, maybe 30, 40, 50, 40 to 50 sensors. Yeah. But let's see how many we need.
I think every one of you already got your idea. And this is just a typical 2,500 ton per day capacity cement plant. They usually have 8 raw material proportioning silos. They have 1 raw material homogenization silo, 1 clinker silo, 17 cooler grades, and then 12 final cement storage silos. For those silos, for each single silo, we will need at least 1 continuous measuring sensor or level transmitter, and we need at least 2 leveling switch, high and low. So in that case, we will count them together. So 8, then we need 8 continuous measuring sensor and 16 leveling switch. And here 1, 2, here 1, 2. At cooler grades, normally we do not need to have continuous measuring sensor. So we will need to have 34 leveling switch, high and low at least. In the final cement silo, we need 12 continuous measuring sensor and 24 leveling switches. So in total, we will have 22 continuous measuring sensor and 78 leveling switches. So you see, that's a high potential in this industry, right?
Counting it together, we have 100 sensors.
Yeah.
This is quite a lot. This is,
yeah, you never thought, right?
Double the number of what I estimated.
Interesting. So everyone says that. So there are a lot of potential here in the cement industry. Hopefully our podcast today would give you some hints or help you to explore more about this market.
Yeah, thank you, Goyen, for your support. It was a pleasure for me to do this webinar with you. And also thank you to you for listening to our webinar. I have one last information for you. Next month, we will have another webinar. This time we will focus on the metal industry. So we prepared also some interesting application, which we solve with our sensors. And I would really hope that you will also join this webinar. So hope to see you there, and goodbye for now.
Goodbye. Thank you for joining us. Bye-bye.